My name is Glenn Sizemore. I'm a technical product manager here at Broadcom, and I work in the VCF platform. Today we're going to be talking about a technical introduction to building a private cloud using VMware Cloud Foundation. Now in today's session we're going to start off with just doing some quick level setting for the room, just to ensure that everyone understands what VCF can and cannot do. And then we'll transition into a demonstration where we're actually going to deploy a private cloud today powered by VCF. Okay? Quick disclaimer, there are no futures in today's presentation. Everything that we're going to be discussing is publicly shipping product, but if in the course of our discussion futures should arise, just know that this is software. It's not done until it's done, and sometimes things take a little longer to build than we anticipate. All right, now in VMware Cloud Foundation, we build what's known as a workload domain. And a workload domain is a combination of compute, network storage, and a vCenter server that is deployed, scaled, and lifecycle managed as a contiguous unit. It's kind of a different way of thinking about infrastructure, but it simplifies a lot of those second-order tasks once you get it up and running. Now, when we deploy VCF, there's a variety of different architectures that we can deploy within. The most common of which is, of course, just a single region deployment where all of our components are contained within what would be deemed a single site for disaster recovery purposes. Now, when we deploy in a single site or multi-site deployments, we have a couple of different options. We can deploy in what's known as a consolidated architecture or a standard architecture. And what that basically means is a consolidated architecture is where you're going to be running the management components alongside customer workload on the same cluster. Standard architecture is where we set aside the management cluster for the purpose of hosting management components, and we only put customer workload in dedicated VI workload domains. Whether you deploy consolidated or standard, it entirely depends upon you. A single management domain in a consolidated architecture is a valid VCF deployment. You don't ever have to get another workload domain. You don't ever have to deploy beyond that if that's enough for you and your organization. But if you're running a larger organization and you're going to need multiple workload domains, then you probably want to deploy a standard architecture and have those dedicated resources for management. Now, if we need higher levels of availability, that can be accomplished by deploying a vSAN stretch cluster. Here we have half of our hosts in one site, half of our hosts in a second site, vSAN witness often in a third site. We tie those three together into one big availability engine such that if we were to lose any one site, your workload would simply restart in the surviving site. Now, this is a very powerful availability tool, but don't confuse it for business continuity or disaster recovery, because vSAN is synchronously replicating any changes that occur inside the environment. So if somebody were to delete a VM from one site, that is synchronously deleted from both sites. If you were to get ransomwared in one site, you are synchronously ransomwared in both sites, right? So this is not business continuity. Now, if you do need business continuity, we can do that. There we would typically deploy VCF in a dual region model where we'd have two fully redundant instances of VCF, and we could optionally use NSX federation to provide consistency policy management and global networking between those two sites to facilitate workflows such as disaster recovery. Now, in a multi-site deployment, we would always make sure that we've got VCF operations, formerly known as Aria operations, deployed so that we could get that single pane and be able to monitor and manage our multiple installations nice and easily. Now, as for your edge locations, there we've got a couple of options as well. We, of course, can just deploy we can deploy a workload domain in a remote edge location as a remote edge cluster. We could also, though, deploy the entire VCF stack at the edge location using VCF edge licensing to reduce our licensing entitlement if we qualify. And that is supported in air-gapped environments. So there's no requirement to have an internet connection to have a VCF deployment and or even in edge scenarios. Now, as far as your far edge goes, there we recommend that you actually deploy with the VVF architecture and just connect back to a vCenter server that is centrally managed in your VCF deployment domain, okay? So just a quick overview of a couple of the various different options as far as deploying VCF. Now, when it comes to the actual deployment itself, in VCF 5.2, it's fairly simple. In order for us to create what's known as the management workload domain, we require 4 vSAN ready nodes. They must be vSAN, there must be 4 of them. It's a hard requirement in 5.2. We take those 4 hosts and then we deploy the Cloud Builder OVA appliance. Cloud Builder is an OVA appliance that contains all of the software and automation necessary to instantiate the software-defined data center for using those 4 hosts. Cloud Builder takes as an input the download parameters workbook, which is an Excel spreadsheet that you get from the Broadcom support portal that contains all of the configuration that defines your particular data center. Your VLANs, your IP addresses, your host names, your service account passwords, all that stuff. That goes in the inputs file. So we feed that inputs file into Cloud Builder. Cloud Builder will then go off and validate the physical infrastructure to make sure that there's a high likelihood of success that this deployment is going to work. Once the validation is complete, we can then kick off our deployment, and Cloud Builder will build our VMware Cloud Foundation environment out of those 4 servers, giving us what we call the management domain. Now, new in VCF 5.2, there's an alternate way to build this. It's called VCF import, and what you can do here is if you have a vSphere 8.0 update 3 or newer environment, then we can go to the Broadcom support portal and we can download our prerequisite information. We can download SDDC Manager, we can download the VCF import toolkit, and download our NSX installation bundle. Once we have all of that available, we can then deploy SDDC Manager on the same cluster that is currently hosting vCenter, important detail, and then install the VCF import toolkit into SDDC Manager. Once we get it installed, we can then use the VCF import toolkit to pre-validate our environment to assess whether or not it is compatible with VCF import. If it is, we can then leverage it to convert our vSphere cluster into our VCF management domain. All right? So it's a different way of standing up the architecture. Oh, they removed it. If at the end of today's presentation, you find yourself saying, you know what, I'm not building this thing, I'm gonna use that import thing he was talking about, there's another session you're gonna need to watch the recording of, and that's 1685. It's a Thursday session, it's already sold out, so you could try to wait list it. We're gonna go through VCF import in excruciating detail during that hour. Today, I just wanted to highlight that it is an option, and I'll call out in a couple of places where it would change things. Now, regardless of how we build our management domain, once we have a management domain, we can then use it to instantiate additional workload domains. We would simply call the create workload domain workflow, which launches an automated workflow that walks us through the configuration of our workload domain, all the various different configurables and questions necessary to get it for our specific installation. Once we answer all those questions and click deploy, SDDC Manager will go off and instantiate our workload domain for us using a fully automated workflow, okay? Now, there are a couple of things in this configuration that I want to explain in slightly more detail just to make sure that everyone in the room is on the same page. And then we're gonna transition, like I said, into a demonstration. The first of which is how SSO works. By default, when you deploy a workload domain inside VCF, you're given the choice to either create a new SSO domain or join the management domain. If we join the management domain, then we join using enhanced link mode and we get a single pane of glass between all of our vCenter instances. If you create a separate SSO instance, then that's what we call an isolated workload domain because it's isolated, right, from an SSO perspective. Now, if we choose to bridge everything to the management domain, we can have up to 14 workload domains in addition to our management domain. But we can add on an additional 10 isolated workload domains in addition to those 14. Or if we're going all isolated, we can support up to 24. So you see how this works. VCF supports 25 workload domains per instance. You can have up to 14 of them in an ELM ring, right? The remainder roll over to isolated. And whether you use enhanced link mode or isolated really comes down to your use case and whether or not you want to administratively separate your users at the vCenter level or if you want to just do it through RBAC. But we don't really force one or the other. It supports both. The other thing that we need to level set on is how storage works inside VMware Cloud Foundation. Now, inside VCF, we have two different kinds of storage. We have what we call principal storage and supplemental storage. Principal storage is the default storage that is added to a workload domain and is used to host your virtual machines. It's what HA uses for FDM, all that advanced stuff. Inside VCF 5.2, the management domain for a greenfield deployment must run vSAN. This includes secondary hosts or secondary clusters. Question in the back. Okay, so if you'd rather use a quote unquote real SAN, then you can use VCF import to build your management domain using either NFS v3 or VMFS over Fiber Channel. But with 5.2, if you're gonna do a greenfield deployment like we're gonna show you today, you have to use vSAN for the management domain. Now, I'm gonna actually argue that your management domain is perfectly happy on vSAN because it was designed for the kinds of workloads that it's hosting. And we get the simple integrated lifecycle management and all the other benefits that come with it, but I don't need to give you the hard sell on it. The management domain has to use vSAN. Now, your other workload domains, there we get flexibility. In addition to vSAN, we can also use VMFS over Fiber Channel, vVols-based storage, or NFS v3. Now, if you have other storage on the floor, we support that. It's just supported as supplemental storage, right? So this is just additional storage that is added to a cluster for the purposes of augmenting its capacity. Is that clear so far? Okay. The last thing I need to touch on before we pivot into our demonstration is how the networking works inside VCF. Because this is a little bit different for most of our traditional vSphere administrators. Out of the box, we require 4 VLANs in order to get the basic vSphere cluster up and running. We've got a VM management VLAN that the management VMs are connected to. There's a host management VLAN that the ESXi hosts are connected to, and then dedicated VLANs for vSAN and vMotion traffic. Now, in addition to these 4 base VLANs, we add a 5th, and that's the NSX logical network. And the NSX virtual network. And inside the NSX virtual network rides all of the encapsulated NSX traffic. So all of the various different network segments and configurations that are inside our software-defined networking, it all rides one physical VLAN, which helps you greatly simplify the physical infrastructure and move your configuration up the stack into the software tier where it's more agile, easier to maintain. Now, on that NSX virtual network, each host, for every uplink that it has, we create what's known as a tunnel endpoint connection, or a TEP. And the TEPs are the logical on and off ramps to and out of that software-defined network, right? So when we expand this out, we go in and we start to create our network segments inside NSX, right? Each of these network segments are essentially layer 2 broadcast domains. They're isolated from one another. And we can traverse east-west easily just by going up and down through those TEP interfaces. And again, just 5 physical VLANs, any number of logical networks running on top of that. So that's our east-west communication, but how do we get out of that network? How do we get out of that NSX virtual network so that we can talk to the rest of the data center? How do we get layer 3? Well, in order to do that, we added an NSX edge cluster. And an NSX edge cluster is a virtual appliance that provides all of your higher level network services, right? It's stuff like it can be a load balancer for Aria. It's your VPN endpoints. It's your firewall, right? It's all that stuff. Now, inside VCF, we have a variety of tailored workflows for deploying NSX edge clusters. We, of course, can deploy one just to do custom tier 2 routing into the data center, just to connect to other networks so that we can talk to them, talk to the world. But we also have dedicated workflows. Sorry. We also have dedicated workflows for deploying a Kubernetes workload management cluster for doing things like IaaS control plane, or we can do application virtual networks, which we'll talk about a little bit later on today. All right? And believe it or not, with that, we've level set. We are ready to get into the actual deployment. All right. So here I've got my Cloud Builder appliance, and we are going to deploy VMware Cloud Foundation. All right, so we're going to just say, yes, this is going to be a VCF deployment. We need to accept the EULA, and then we need to upload our download parameters workbook. And if you've never deployed VCF before, start with the Excel spreadsheet. It walks you through the configuration, right? This is one of those things that we're changing in the next release, by the way. The Excel spreadsheet's going away. It's going to be a proper UI in the product. But for right now, it's easier to outload those parameters in an external file dependency. Now, if you do a lot of these deployments, right, if this isn't a one-time thing for you, but like your PSO or a partner and you're going to help a lot of customers, you might want to get familiar with the JSON specification. I find it to be a little bit easier to modify if you're doing multiple repetitive kind of deployments. Okay, so we've uploaded our download parameters workbook. It contains all the details for my physical environment. Now when I click next, what's going to happen is Cloud Builder is going to go off and it's going to validate the physical environment. It's going to actually test everything that I fed into it, and it's going to see whether or not a deployment would succeed. Now, once my validation is successful, which just takes a second here, then we can go ahead and kick off our VCF deployment. Now, in the real world, this took right at 4 hours. I've sped up this demonstration for the purposes of today because we don't have 4 hours to sit here together. But what I will do is explain what's happening. I'll answer your question in 1 second. So what we do is we grab the first ESXi host and we configure it up until the point that it is ready to host a virtual machine. Once it can host a VM, we then deploy vCenter onto that first ESXi host. Once vCenter's up and running, we add all the ESXi hosts into vCenter and create the vSphere cluster. Once we've got a cluster, we can create our virtual distributed switch, all our VM port groups, VM kernel interfaces. Once we have our VM kernel interfaces, we can go in and configure vSAN. Once we've got vSAN configured, then we're good to go. We can start to deploy the NSX managers. Once the NSX managers are online, then we go in and start to configure them, right? Configure the management endpoint, transport overlays, those tunnel endpoints, all of the details that go into that software-defined network. And then once NSX is fully up and operational, then we transition to deploying the SDDC Manager appliance. Now, SDDC Manager, if you're not familiar with it, is going to be the appliance that we use to manage our environment going forward. This is going to become the central hub in 5.2. In moving forward beyond 5.2, it'll be VCF operations, but for 5.2, SDDC Manager still plays a very prominent role in our user experience. Now, once we've got SDDC Manager up and running, at this point, the rest is just configuration. There's well over 150 manual tasks that are fully automated as part of Bring Up. And all of it is handled through the integrated workflow. And as we can see here, after right at 4 hours, I can see my deployment has succeeded. And if we go ahead and click Finish, we can launch our SDDC Manager interface. We log in with the credentials supplied during Bring Up. And we are greeted with SDDC Manager, right? We can see here we've got one management domain with our 4 hosts. So we've got a starting point of a standard architecture. Now, the next step typically would be to commission hosts to bring more inventory into the SDDC Manager environment. In order to commission hosts, we first need to load ESX, configure the host name, local management network, NTP, and make sure that the host certificate matches the fully qualified domain name. But that's it. Every other aspect of ESX is going to be managed by VCF, right? So we just acknowledge that my hosts have been prepared, and we're going to go ahead and kick this off. We could add them one at a time to the wizard, but I find it much easier just to do a bulk import. Again, using JSON, the specification file is right here if you want to use it yourself. We'll simply upload that file and then kick off our validation. A couple of seconds later, we can see all of our hosts are valid, and we've got 12 hosts getting ready to add to the inventory, and we'll just click commission. And now what happens is SDDC Manager physically connects to each one of those ESXi hosts, and it discovers what that host is. It also adds to the inventory the kind of host that we're adding. Is this a vSAN host, a vSAN Max host? Is it a compute-only node? Is it an NFS or fiber channel host? All of that is contained in the commissioning process and plays into what you can do with the hardware after the fact. But as you can see, now that we've commissioned our hosts, we've expanded our inventory. I've got a total of 16 ESXi hosts available, 12 of which are unallocated. So now we can go ahead and use that capacity. How would we use it? Well, if we just wanted to expand an existing workload domain, we'd simply go to the workload domain in question, navigate to clusters, select the cluster we would like to grow, and say add hosts. A very simple wizard is launched. It asks us which host we'd like to add. We just select the hosts, configure our uplinks, select our ESXi licenses, review the config, and then kick off the workflow after a quick validation to add those hosts. And about 30 to 45 minutes later, our cluster will have been expanded by, in this case, 2 hosts without us having to do anything else. It's very much fire and forget, similar to a desired state engine. You go into SDDC Manager, you declare what you want the infrastructure to look like, and then you walk away and you let SDDC Manager actually deliver that request. Now, if we wanted to go beyond just expanding an existing workload domain, we could easily do that. We just come up here to workload domain, and we could say, add new VI workload domain. First question, what kind of storage do you want to use? Because this is a very pivotal part of the architecture. Now, for my demonstration today, I am going to be using vSAN. Unfortunately, the hosts that I'm deployed on do not support ESA, so I'm going to be using OSA today. If you are buying hardware for VCF and you're buying vSAN hosts, make sure you're buying ESA. Do not get any more OSA deployments on your floor than you absolutely have to. All of our future innovation is going into the ESA engine. But I am going to deploy ESA today. Now, for my workload domain, I'm simply going to give it a name, and then I configure the SSO. And remember, if I wanted it to be an isolated workload domain, I would just create a new SSO domain, enter in what I wanted. I could use the same thing. They could all be vSphere.local. They don't have to be unique. It just means that they're not going to use enhanced link mode when you select join, create new SSO domain. But for today's demonstration, let's join the management domain. Next, we configure our cluster. We just give it a simple name. And then we configure lifecycle management. Now, by default with VCF 5.2, we default to using VLCM-based images. The only reason to uncheck this checkbox is if you are physically putting like Dell and HP servers in the same cluster, right? That is the only reason in 2024 to continue to be using VLCM-based baseline. Otherwise, you really want to be using images. There's just a lot of advantage there, which is what we're going to be doing today. So I'll just select my image. Now for vCenter, we simply give it a fully qualified domain name and a password. That's it. Everything else is managed. And then we get to the network. And in VCF 5.2, there's this little button right here. And if I click that button, it exposes this toggle where I can select vSphere networking. When you select this, the subsequent workload domain that is created does not deploy the NSX managers. There is no overlay. There is no transports, right? It's just using traditional VDS switches. This option exists for very select edge cases where the additional scale that you can get through vSphere networking is required. For example, if we're talking about those remote clusters, right? If you're deploying with NSX, we can have 1 cluster per remote workload domain. If we deploy with vSphere networking, we can get 30 clusters per remote workload domain. So in those very rare edge cases, that's what this checkbox is for. But really, you're missing out on a lot when you click it. And I'm going to make a strong case today that you always want to be deploying the NSX managers, even if you have no intention of ever using logical switching and routing. Even if all you're going to do is VLAN-backed port groups, there's still an advantage to deploying the NSX managers. There's some security advantages. There's a lot of visibility and monitoring and manageability. And then going forward, it helps you ensure that you're on the right track with VMware Cloud Foundation. Now, fortunately, to deploy NSX is a trivially simple process. We just need 3 fully qualified domain names, 1 per NSX manager appliance, and then a single domain name for the logical endpoint for our management. Scrolling down, we select the manager appliance size. Large is fine for me today. I only have 16 hosts, and then we give it a password. That's it. Everything else is managed by VCF. For vSAN, since this is OSA, I need to tell it to turn on deduping compression. If this was ESA, I wouldn't need to answer anything because it's all managed. And then we get to the host selection, where we just select the hosts we'd like to add to our workload domain. Next, we get to the virtual distributed switch configuration. Your VDS config depends on how many physical interfaces you have. By default, the VVS architecture calls for 2 physical NICs per ESXi server. And that's what the default profile assumes. And as you can see, my server today has 2 physical network adapters available for use. If you had more than 2 and you wanted to have multiple VDSs, if you wanted to put your NSX overlay traffic on a dedicated VDS using a DPU, or you wanted vSAN to be on a dedicated VDS for enhanced performance, then all you do is you click that little button down at the bottom, create custom switch configuration, which launches a little mini wizard that walks you through the configuration of your particular virtual distributed switch. But again, in today's demonstration, I'm just going to go ahead and deploy the default. Next, we'll just select our licensing. We could also just license later if we didn't yet have it available. It would deploy in evaluation mode. And then we hit go. And this is similar to bring up. It'll go out, it deploys vCenter, it adds all the hosts to vCenter, creates the vSphere cluster, creates the VDS, creates the VM kernels, configures vSAN, deploys NSX managers, right? The only thing that we don't do when we create a new workload domain that we do during bring up is SDDC manager. That's the real difference between the two. But as we can see, after about 90 minutes, I now have a new workload domain. Now, if we wanted to scale this environment up further, we of course could do that. We'd simply go in to the environment, and if I just go to clusters just to take a look, we only have cluster 01. If I wanted to add a cluster, that is also a trivially simple operation. I simply say add cluster. Launches a simple workflow. I'm going to say I want a vSAN cluster. I give my cluster a name. I select my baseline image. I configure vSAN. Notice it's giving me this option, vSAN compute cluster. That's showing up here because cluster 01 already has a vSAN data store. We can mount that storage as our principal storage in cluster 02. So cluster 02 could be a bunch of blade servers. They don't have to have any NVMe drives, and they could still use vSAN, even if it is OSA. Although the better way of deploying this architecture is with vSAN Max in an ESA architecture. But again, we're just going to turn on dedupe compression. We select the host we'd like to add to our secondary cluster. I'm just going to burn up what's left of our inventory today. Configure our VDS. Configure our licenses. And say go. And about 30 to 45 minutes later, we have cluster 02, 5 hosts ready to be consumed, ready for workload, right? It's just set it and forget it, fire and forget. It makes it trivially simple to sling infrastructure when you're using VMware Cloud Foundation. The task of deploying vSphere is not the challenge with VCF, right? VCF makes that trivially easy. The challenge is move elsewhere in the infrastructure, into things that you typically don't have time to think about. All right, so what have we done? So far I'm showing you a lot of an interface most of you probably have never seen, but you've all seen this one before. And as we can see, what have we done today? Well, we deployed a new vCenter. We can see our management data center. We have our management cluster 01. Then we have our second vCenter that is attached in an ELM ring. It's all connected. We can see our multiple different clusters, 10 hosts, right? At this point, it's just vSphere. It's the exact interface, everything that you already know. Okay. All right, so what's next after this? Well, typically the next question that I get once we get this far into the discussion is, okay, so, deployment's easy, I get that. What about lifecycle management? How do you do that? Well, the way LCM works inside VCF is it's a fully integrated experience. The SDDC Manager appliance connects to the online depot. It's either physically the Broadcom.com web server, or it's an offline depot that you maintain, but for all intents and purposes, SDDC Manager is connected to a depot. When we release a new version of the software, it hits the depot. You are then notified inside SDDC Manager that there is a new update available. We can go in and review those updates, read exactly what's fixed, what the hot notes are, what components are affected, etc. Once we determine where we want to actually deploy this patch, we can then go run pre-checks inside our environment to assess its health and whether or not a deployment has a high likelihood of succeeding. Once our pre-checks have been passed, we can then go ahead and schedule the upgrade. You could also kick it off to run immediately. You don't have to wait, but typically these things are done in an outage window, so it's common to schedule. When we get to the scheduled outage window, SDDC Manager kicks off the update process and walks through the upgrade in the appropriate steps, right? You just tell it, I want to install 5.2, and it worries about all the details that go into that. When is NSX Manager deployed? When are the edge clusters upgraded? When do we actually have to worry about ESX? What about vCenter? All of those details are handled by the platform. You just declaratively ask it to get you to a specific version, and the platform handles the rest. And of course, once the update is done deploying, we can go back and review and see our status progress. Okay? Now, if you'd like more detail on lifecycle management, another session I'm going to point your attention to is 1605. My friend Eric Gray and coworker is going to go through lifecycle management in greater detail. So if that's something you're interested in, then definitely check that out. Okay. So we took a look at installation. We took a look at cluster expansion. We've played around a little bit with VCF. But honestly, if I'm coming clean with you guys, so far all I've shown you is software-defined data center. And the title of this session was very clearly private cloud. Does anyone know what's missing? Cloud integration, which for us is VCF operations and VCF automation, formerly known as Aria operations and Aria automation, right? So now the next step in this deployment is to get Aria deployed. And again, I'm gonna call it Aria in today's session because if you were to go and deploy this in 5.2, the UI still says Aria, but we have rebranded these products. So going forward, it's VCF operations and VCF automation, but just do the mental mapping for me. Okay. So the way this works inside VCF is SDDC Manager contains a built-in workflow to deploy the VMware Aria Suite Lifecycle appliance, otherwise known as VASL. And VASL is then responsible for deploying the Aria Suite. Once the suite is deployed, we can then connect it to your workload domain and start to manage and operate as a cloud provider. Sounds pretty simple, right? It's not. It's actually a little complicated. It's complicated enough that I'm gonna recommend that you actually spend the time to go and find the VMware Cloud Foundation Planning and Preparation Workbook. Contained inside this Excel spreadsheet is every single IP address, DNS name, service account, certificate you will need to deploy the Aria suite. And trust me, starting with the planning phase and figuring out what all those names are gonna be, what all your IP addresses are gonna be, it is the difference between this install taking 2 days and 6 weeks, all right? So start with planning. Now, once we've got the planning done and it's time to actually start the deployment, we need to start by getting the SDDC Manager ready to accept the Aria suite, which starts with deploying an NSX edge cluster because Aria is gonna need a load balancer. Important, although the Avi load balancer is what you use if you want to use our load balancer for your public workload, we do support the inbuilt NSX load balancer for the purposes of Aria. So you don't have to buy Avi to deploy Aria. Now, once we have the NSX edge cluster deployed, we can then deploy application virtual networks. Once AVN is up and running, we can then download the VMware Aria Lifecycle install bundle to SDDC Manager. And then once we've got it downloaded, we can then deploy the VASL appliance. Once we've got VASL deployed, we then use it to deploy the Aria suite. All right? Let's take a look. Yes?
What is the role of workspace one in this picture? Is it solve the problem of an SSO?
Yeah, it acts as the identity manager for operations and automation. So you can integrate with Okta, but I don't think it can be replaced. I think you need to use the Workspace ONE broker if you want to actually deploy and get identity management inside the Aria suite. Okay. So let's get our environment ready, right? So the first step is we need to add an NSX edge cluster. So how do we do that? We're gonna come in here and right there in our drop-down menu, add edge cluster, all right? We have prepared our physical environment. We are ready to deploy our edges. So now I just need to fill out a little wizard here. And I'm gonna start by giving my edge cluster a name. This is just a logical name that's gonna appear inside NSX. It's not a DNS name or anything like that. I enter in my max MTU, my tier 0 router name, and my tier 1 router name. I select my edge profile type. Default is good for me today. And then I give NSX a bunch of passwords. Next, we tell VCF what this cluster's for, right? Is this just tier 2 routing or is this Kubernetes? Like, why are you deploying this cluster today? In our case, we're deploying it for application virtual networks. And we're gonna default to BGP, so I need to enter in my autonomous system number. And then we get to the actual edge node configuration. We can see the little note at the top there. A minimum of 2 edges is required because this is an active-active installation. So there will be 2 virtual machines deployed as part of this edge deployment. So now we just need to provide the details for each one of these edge nodes. So we start with a fully qualified domain name and which physical cluster we'd like the VMs created in. We select our clustering type. I am layer 2 uniform. We give it a management IP address and gateway on the management VLAN. We also configure those tunnel endpoint connections for the NSX edge clusters and a VLAN for those TEP interfaces. And then we've got 2 uplinks, right? One for redundancy. And we're just gonna enter in the VLAN ID, IP address, and then on that subnet, what is the router that we're connecting to, right? In this case, .16.10. What is that router's ASN, and then what is its BGP password if it has one. We'll fill that out again, this time for the second interface. And then we just add that edge node. The wizard helpfully doesn't erase the defaults when we add an edge node because, quite frankly, most of these stay the same. So to add the second node, we're just going to update the name. We're going to update our management IP address. Scrolling down. Update our tunnel endpoint connections. Our tier 0 uplink, and then our second tier 0 uplink. Everything else stays the same. And just like that, we've got a pair of edges. So we have filled out the wizard for our edge cluster deployment. We'll run a quick validation where NSX is going to go and actually validate that this deployment has a high degree of likelihood of succeeding, right? And then once those checks have passed, we can then kick off the deployment. And in about 30 minutes, we'll have an NSX edge cluster fully up and operational and ready for us to go in and take a look. And if we just take a look right here under edge clusters, there we go. Management edge cluster 01. Nice and happy, everything's active. So that's the first step down. We have an NSX edge cluster. The next step is we need to add application virtual networks. Well, fortunately, again, it's right there, nice and easy. Add AVNs. So we'll just collect that. What are we adding an AVN for? Well, we are adding it for the VMware Aria suite. All right, so we're going to select that. In my deployment, I'm going to be using an overlay-backed NSX network segment, but you could do a VLAN-backed network segment if you were doing VLAN-backed for everything. Excuse me. We select our NSX edge cluster and our tier 1 gateway. And then it asks us for a pair of subnets, the first of which is referred to as the region A subnet, and it is what we call the local network. Right? This is the network where any Aria components that are dedicated to this site and only this site will live. It's things like logs and agents and monitors, that sort of stuff. Right? So we'll just give our region A a name, give it a network, subnet, default gateway, and maximum MTU. And then we need to define the X region network. And the X region network is the global network that is used to deploy the Aria suite. This is where ops runs, it's where automation runs, it's where VIDM runs. And the reason we call it the global network is you have the ability to stretch it across multiple VCF instances such that a single Aria install can monitor multiple VCF installations. So you don't have to do the full install for every VCF deployment. You can just kind of do it once and then reuse that over and over again. All right, and then we'll just hit finish, and this is very fast, less than 5 minutes. It's just gonna go off, create a couple logical network segments inside NSX, and then pop it right back. Okay. And with a quick refresh, we can see we've got our application virtual networks, everything's configured, we've got region A, X region. I've already downloaded the Aria installation bundle, so that pre-check has already been taken care of. So we are ready now to move to the next step, which is to deploy the VMware Aria suite. We'll just come here and say deploy. This is a very easy configuration. We're asked 4 questions. What is your fully qualified domain name of your Vassal appliance? Give me a free IP address in the X region network. This is going to be used to configure routes inside NSX. And then give me a password for the system administrator and root account. That's it. Those 4 inputs, we'll say finish. And now SDDC Manager is going off and it's going to deploy that Vassal appliance in what we call VCF aware mode. And we call it that because when it's deployed like this, Aria knows that it's running in a VCF environment. And because it knows that it's running inside VCF, then some of your configuration gets simple. Like it understands what your workload domains are, it knows what your clusters are. You don't have to teach it every single little aspect of your infrastructure. But as we can see in this case, we're up and running. And there we go. Okay. Now the next step from here would be to go and connect into the Vassal appliance and we'd create our certificates and our service accounts. We would upload the Aria installation bundles so that the bundles were present inside Vassal. And then we could start clicking these links down at the bottom. We'd start with Workspace ONE, deploy Workspace ONE Access, get that up and running. Then we deploy operations, get Aria operations up and running, get Aria operations for logs so that we get those enhanced diagnostics. And then finally, deploy the VMware Aria automation, otherwise known as VCF automation. And it is this last step that converts your software-defined data center into a private cloud. Because Aria automation is what provides those self-service portals, the consumption interfaces that are the defining aspect of private cloud. All right? Now, in truth, the Aria installation would have been a 2-hour session in itself. I'm not going to sit here and tell you that it is a light install. It's a rather heavy install at current, but it's very much worth it once you get all the way through it. So we're not going to be able to fully finish out deploying this private cloud, but as you can see, VCF makes it very easy to get to the point where we're ready to begin that installation. All right. And with that, we've got 5 minutes left. Questions?
So I'm frequently in a position where I literally start with cloud hardware and build a network. And I know that currently, like vCenter really wants DNS up and running. But I run into a chicken and egg problem. So I have a cluster where I host DNS VM. I don't have DNS. So is this really depending on DNS? And how do I overcome that?
It is dependent upon DNS, but it also is dependent upon you already having a ESXi host somewhere in the infrastructure, because the Cloud Builder OVA appliance needs to run somewhere. I guess you could run it in Fusion on a laptop, but you could do the same thing. You could jumpstart DNS services, on a laptop if you have to. But yes, unfortunately, we do need to have DNS fully functional for us to do a deployment. NTP needs to be fully functional as well. Hear you on the chicken and egg scenario, but it's just one of those things. In order for us to do the deployment, we have to use fully qualified domain names so that everything can be fully secured, and we've got SSL certs that equal back. So it's just a core dependency that we have.
So I could just go stick a DNS VM on the first ESXi host.
Absolutely, yeah. Yeah, you could stick a DNS VM. Often in our labs, we'll just spin up an Ubuntu interface, get bind up and running, just enough to get it started. And then once it's installed, it's easy enough to do a zone transfer and get your DNS moved somewhere else. Yes, sir? Does it require what? Yeah.
Are you starting with bare metal hosts that you have to pre-install the ESXi on all hosts?
Yeah, great question. So the question was, with Cloud Builder, are you starting with bare metal hosts? The answer is no. But in order to run Cloud Builder, you must first install ESX, give the host a management network, give it a host name, and make sure that the host certificate matches that host name. The last step is what gets most people up.
How would you deploy ESXi? Is it through Pixie Boot?
So there's a number of ways to do it. William Lamb has a great session this week where he's going through doing ESX installations at scale and showing how to do Pixie and integrate all of this into VCF. But the answer for us is whatever works for you.
What you just deployed, you said they also bare metal hosts, right?
Yes.
So how did ESX get put on the bare metal?
In my lab, I connected to the DRAC and attached an ISO.
That's a manual step. The Cloud Builder doesn't do that.
That is correct, yes. Yep, yeah, the ESX installation is still manual. It's all the configuration and automation after that installation that is automated.
We have several vCenter environments like SDN, Pod, Oracle has a separate ones. Each vCenter environment requires work magic.
No, so each VCF instance has a management domain, one management domain, and it can have up to 24 workload domains. Now, every domain has a vCenter. That's really what it is. A domain is a vCenter.
So if we have some air gap or SQL has completely separate for licensing reasons, if they have this thing where it has completely separate, but in that case, it's all separate. We have to have separate management name for that.
Let me connect with you in 1 second. We'll talk about that in slightly greater detail. All right, ladies and gentlemen, today we took a look at the basic fundamental requirements of how VCF works. We walked through a basic deployment. We explained how to convert a software-defined data center into a private cloud, and we took a look at what that looks like. Again, this wasn't intended to be a deep dive. This was an introduction. With that said, I'm very interested in your feedback. Was this useful? Right? Did you learn something? If so, please tell me in the survey. If you wanted more details, if you think I skipped over something and it was confusing, again, feel free to call me out. Let me know, right? I'm genuinely interested in the feedback. And with that, I'm going to thank you very much for your time today, and I'm going to hope everybody has a great week here at VMware Explore.